Okay, so let's say the price of an item or any number for that matter is increased by 10%. First increased by 10%, and then this new price is increased by 20%, and then this new price is let's say decreased by 16.66%. I'll put a plus to indicate increase. So let's say this is what is happening to the price, and the question is, what is the overall percentage change in the price from this first price to the third price, or what is the percentage relationship between the new price and the oldest price? Okay. So now basically what we're dealing with is successive percentage changes. Okay. Now this price has increased by 10%. So my first equation would be this price has been increased by 10%. We know increase of 10% is a multiplying factor 11 by 10. This is the new price. Yeah. Instead of writing this way, I'll just think of this whole thing as a new price. Now this new price has further increased by 20%, right? So 20% of what? 20% of this has been added to this, or since this is the new price, we can multiply this by 6 by 5. So this has increased by 20%. Okay. You could have written that this is equal to the second new price, right, after these two increases. But again, instead of writing, just think of it as a bracket that this is the second price. Now it has reduced by 16.66%. Reduction by 16.66% means a multiplying factor of 5 by 6. So this is equal to the third new price, right? So now if I look at the multiplying factors, because the story is over, this gets cancelled and I get P into 11 by 10 is equal to the third new price. You don't need to write the third new. I could have simply put one symbol only, but just for the order of the story. So P into 11 by 10 is equal to the new price. That means the new price is 10% more than the old price. Yeah. So successive percentage change, no difference for us. We have to just set up a chain of multiplying factors. There was a price P. It was increased by 10%, so it became this. Now this was increased by 20%, multiplied by 6 by 5, it became this. Now this was reduced by, so we get the same thing. So as far as multiplying factors is concerned, this successive percentage change or a chain of percentages in the story wouldn't make too much of a difference. You just have to set them up. We'll look at a few more examples of this. Okay, so this is our story. We'll figure this out. Let's say there is an item and the price of that an item is P. Okay, so A sells it to B at a profit of 25%, or A increases the price by 25% and sells it to B. Okay, B for some reason had to reduce the price by 20% and sell it to C. C further reduced the price by 12.5% and sold it to D, right? And then D sold it to E. We do not know for what percentage, and it is given that E paid the same price as A paid for it, right? The final price that E paid for was P only, right? So what is the at what percentage increase, decrease did D sell it to E? Okay, so this is nothing but a chain of story. So let's start with the price. A paid P rupees for it. He increased it by 25%, so multiply it by 5 by 4. This becomes the price B paid for it. B reduced this price by 20%, that means a multiplying factor of 4 by 5. Yeah, right? Now this price is what C paid for it. C further reduced it by 12.5%, which means a multiplying factor of 7 by 8. And then this is the price D paid for it. Now D did further something. There must have been a multiplying factor. Let's call it A and B. And then after that the price became P again, right? Because we know that E paid the same price for it as A paid for it. So nothing, again we have the same series of multiplying factors only. This gets cancelled. I know this P will also get cancelled. So A by B I get as 8 by 7. Yeah. That means the multiplying factor involved is 8 by 7, and 8 by 7 means an increase of 1 by 7 or increase of 14.28%. Okay. Yeah. So finally D increased the price by 14.28% and sold it to E. Okay. There is a formula available for this successive percentage changes also. Now most of you, if you're referring to other material or learning from other people, you would have heard of this formula, you might know this formula, but remember that the formula is very limited. Okay, so the formula is this. I'll explain each term. A plus B plus AB upon 100 is equal to R. So let's say when a number n goes through two successive percentage changes A and B, is that okay? Now this n might be a problem, so think of it as a price or something where it is increased by A% and then again by B%. So it is going through two successive means one after another percentage changes. So if it is going through two percentage changes which are A and B in succession, the overall change that n will go through, and n to n dash, overall percentage change from n to n dash will be R, which is equal to A plus B plus AB upon 100. Whenever you look at this formula or any such formula or n, which is general kind of information, quicker way to learn this is to go into specifics and see this in operation. So let's say the price of an object, I'll give you the price also, which is let's say 250 rupees, is increased first by 10% and then by 20%. Okay, remember it is increased first by 10% and then by 20%. So it is, the price is going through two successive percentage changes, first by 10%, so from P it is becoming 10% more than P, and then this whole new thing is increased further by 20%. Okay, so we know the formula A plus B here, this is A and this is B, and the question is what is the overall percentage change in the price, or what is the new price. Okay, either way. So I'll use the formula A plus B plus AB upon 100, A plus B, so it will be 10 plus 20 plus AB, which will be 200 upon 100 is equal to R. So 10 plus 20, this gets cancelled, 30 and 2, so R is equal to 32%. That means the overall percentage change in the price is 32%. Okay. So the new price I can find out by 250 rupees plus 32% of 250 rupees, and I'll get my answer. Okay. Now how I calculate this 32% is up to me. 32 by 100 I can do into 250, multiply, or find out the multiplying factor for this. We'll do that in a second. Okay. So overall percentage price change is 32%. Okay. Now we already could have done this by multiplying factors. Where price is P, it is getting increased by 10%, that means multiplied by 11 by 10. It is further getting increased by 20%, so multiplied by 6 by 5, and this will give you the new price. And if we work this out, we get 66 by 50 or 33 by 25, which is equal to P dash. An increase of 8 by 25, okay, the way of thinking would have been they're equal, so there would have been 25 by 25, but there's 8 by 25 extra, or you can write this as P plus 8 by 25, P is equal to P dash. 8 by 25, now 1 by 25 is 4%, so 8 by 25 would be 32%, so there is an increase of 32%. So we're doing the same thing, but we have a formula and where we're using the general multiplying factor whole architecture that we have learned earlier. Okay, so now why know the formula at all? Okay. Oh, also by the way, when you got this 33 by 25, this 32% increase means 8 by 25, so the calculation becomes easier. 25 tens are 250, 8 tens are 80, so 250 plus 80, the new price would be 330. I hope that was right. If we make any errors while doing this, I'm sure you can fix it. We are more focused on the logic anyway. Okay. So yeah, two ways of doing it. So why do the formula at all? The formula will be useful when the numbers I do not know the percentage fraction equivalence, or it's not working out too well. So let's say the same price was increased by 15% and then again by 15%. Okay. Now I can do the multiplying factor here. 15% increase, right? 15% is 3 by 20. Why? 1 by 20 is 5%, 3 times that is 15, so 3 by 20. Increase would mean 23 by 20. Okay, if this idea is new, alien, or if you're getting stuck here, you need to go back and revise and learn how to make multiplying factors or understand how this is working. So P into 23 by 20. Now this is the new price. Once again it is increased by 15%, so another 23 by 20, this is new P dash. So now you have it there, but there's 23 into 23 and this would be upon 400. This will be some number which you'll have to work out and think again that what is the percentage, what is 23 into 23, we can work that out also. 529, okay. So P dash is 529 by 400, an increase of 129 by 400, okay. Now 1 by 400, sir, we have not seen in the tables, oh my god, what to do. So we know 1 by 4 is 25%, 1 by 40 would be 2.5%, 1 by 400 would be 0.25%. So 129 into 0.25% I'll get something, okay, which can be worked out, which is not a problem again, okay. But we are finding it difficult, right? We're going somewhere and it's taking us time. However, the formula here would have been far more convenient. I know the price is going through two changes, A and B, and the formula is 15 or A plus B plus A into B upon 100. So 15 plus 15, which is 30. 15 into 15 is 225. 225 by 100 will give you 2.25. So this will become 32.25. So this was slightly faster for me. So maybe sometimes the formula would be convenient, but otherwise also, if you look at percentage changes, and if I had put one more percentage change here, the formula will work only for 2% change at a time. So if there were 3, you would find this result and use the same formula again with this value and this value as A and this value as B. So formula has a limitation. The multiplying factor could have worked on a longer chain also. But remember that converting this, you should learn this one. I mean, it will be a good idea to know how to convert any multiplying factor into a percentage equivalent anyway. So I hope that you have understood the formula and you know how to apply it. We'll see a couple of situations where the formula can go wrong or how the application might be troublesome. Okay, so let's say the length of a rectangle is increased by 20% and the breadth is reduced by 20%. Length is increased by 20%, breadth is reduced by 20%, and the question is, what is the percentage change in the area? Okay, we want to use the A plus B plus AB upon 100 is equal to the overall percentage change formula here. So now I know that the area, we still need to understand that logic, that the area is directly proportional to length and breadth, and whatever happens to length will happen to area, and whatever happens to breadth will happen to area, okay. We have done such a question with multiplying factors earlier, and we'll do it again this one also. But so A will go through the same percentage changes as the length is going through and the breadth is going through. That means A will go through 2 successive percentage changes, this and this. You can call this A, you can call this B. So the overall percentage change in the area would be 20. In this case, this is minus 20 because there is decrease. So the formula A plus, but there is a minus 20 here. So you can just write out minus 20 plus 20 into minus 20 upon 100. I'm using the same formula, is equal to the overall change. So this becomes 0 and this becomes 4 minus 400 upon 100, which becomes minus 4. So my overall change is 4%, that means minus 4%, or the area has reduced by 4%, okay. So I hope the formula made sense here. The same way by using multiplying factors would have been area into 6 by 5 into 4 by 5 is equal to the new area, which becomes 24 by 25, and which means the new area is 1 by 25 less than the old area. 1 by 25 is 4%, that means the new area is 4% less than the old area, or the area has reduced by 4%. Yeah? Okay, this is where one can go wrong or not know how to apply the formula. So let's say the length has increased by 50%, but the area has only increased by 20%. Okay, length has increased by 50%, but the area has only increased by 20%. What is the percentage change in the breadth? We don't know, so it could be gone up or down. So now the formula becomes slightly tricky to use, because we have to understand that the area has gone through two successive percentage changes, this and something here, and the overall change is this. So if I want to name them, this would be A, this would be B, and this would be that R that we were talking about. So in this case, we have A plus B plus AB upon 100 is equal to R. We know R, which is the overall percentage change, we know which is 20%, so I can put it here, 20%. This 50% can go here. We do not know B. Where people go wrong is they just see these two percentages and they do 50 plus 20 plus 50 into 20, which is wrong. Why? Because yes, you have 50 and 20, but they're not A and B. I mean, in the situation, they're not the same thing, okay? So, and right, so we figure this value out, and if I reverse it, I'll get the value of B. So which is not a big problem as such, okay? However, the other way of doing it would be that what is happening to the breadth directly. We know inverse variation also. So when the length is increasing by 50%, we know it in variation that the multiplying factor for length is 3 by 2. For breadth it would become 2 by 3. That means a reduction of 1 by 3. That means a 50% increase means a 33.33% reduction. So I am using the formula minus 33.33. Now area has increased by 20%, that means breadth should increase. So that means the breadth is going through two successive percentage changes, one of which is this, which I'll use directly. But the other one again I can't use in the formula, okay? So one has to be careful here. I'll have to convert this information into this first. Plus 20 plus minus 33.33 into 20 by 100, and I'll get the value here, okay? So remember, I think the earlier usage was easy. 50 plus B plus 50B upon 100 is equal to 20. Solve this and you will get the value of percentage change. We can do this very quickly to get to the answer, not by this, but by the multiplying factor method. The breadth is inversely proportional to length and directly proportional to area. This is nothing but the area is proportional to length dot breadth formula rewritten, okay, rearranged to my benefit. So the area multiplying factor will come to breadth directly, and the length multiplying factor will be flipped. So breadth into 20% increase, which means 6 by 5. And 50%, that means new length is 3 by 2 of length. The multiplying factor for length is 3 by 2, so multiplying factor for breadth would become 2 by 3. This would give you the new breadth. This becomes 4 by 5, which means a reduction of 20%. That means the breadth has reduced by 20%. If you solve this equation, you will get 20% only, or minus 20% rather. Okay, so I hope you've learned the formula, how it correlates with your multiplying factor method, and what is the possible error, how to use the formula. Essentially, you should know A, B, and there is a R also, or a resultant also. And depending on the story, what is given and what needs to go where. Okay. Once again, a few problems. You've seen the problem number 1, and now we know almost everything to do with percentages, including the formula, successive percentage change formula. But now we'll just look at a few problems and see how it applies. The problem number 1 you've already seen. Length of the rectangle increases by 9.09. That means the new length 9.09 is 1 by 11. So it is 12 by 11 of the length, right? By what percentage should the breadth of the rectangle decrease to maintain the area? Maintain the area, that means the new area is the same as old area. That means the multiplying factor for length is available and multiplying factor for area is available. I know breadth is inversely proportional to length, so this will become 11 by 12 and 1 is equal to the new breadth. That means the breadth has reduced by 1 by 12. Yeah, numerator is 1 less than the denominator and the denominator is 12. The breadth has reduced by 1 by 12 and 1 by 12 is 8.33%. That means the breadth has reduced by 8.33%. Okay, minus 8.33%. For this one, we should know that the principal relation that we're looking at is distance is directly proportional to speed and time, right? You can think in your head, when if you increase the speed, distance increases. If you increase the time, distance increases, okay? Now, traveling from home to office, if I increase my speed by 37.5%, that means the new speed, 37.5% is 3 by 8. Increase by 3 by 8 means 11 by 8. So new speed is 11 by 8 of the old speed. What percent of time would I save? That, and we're talking about traveling from home to office. That means the distance has not changed. The distance in the story is the same. The old distance, new, because there is a change, but distance has not changed at all. Okay. So I know the multiplying factor for speed and I know the multiplying factor for distance. Okay. Now, so that means I can move all my stuff on one side where I mean we've done this earlier in variation. So time is directly proportional to distance and inversely proportional to speed. So multiplying factor for time is 1, multiplying factor for speed is 11 by 8, for time it would become 8 by 11. This is equal to the new time. So the new time is 3 by 11 less than the old time. 1 by 11 is 9.09. So 3 by 11 would be 27.27. So the new time is 27.27% less than the old time, or the time has been reduced by 27.27%. Stop. This is an interesting question because once again we get to repeat the idea that the best possible way of finding a percentage relationship between two numbers is to put them in the numerator and denominator form. Rest would be easy, okay? So the story goes, while preparing the price tag, instead of increasing the price by 12.5%, so the price, let's say, is P. I will be doing some arrangement which is obviously I've already done in my head, so it will become very, very easy, but we'll do the longer way also. So the price he was supposed to increase by 12.5, that means he was supposed to do 9 by 8 P, right? Why 9 by 8? Because 12.5% is 1 by 8, increase of 1 by 8 is 9 by, I mean we know this is 9 by 8. But instead he decreased it by 12.5%. So what he did was, he did this calculation, 7 by 8P, a reduction of 1 by 8, okay? Right? You see, so this is what he was supposed to do. The question is difference on the price or compared to what should have been. So this is what should have been, right? And this is what is, okay? So now the question is, find the percentage difference in the price on the tag compared to what should have been the price tag, right? So this, and basically the percent relationship between this and this. So that's why I've already put them in the numerator by denominator form, and see how easy life could be. So this essentially reduces to 9 by 7, okay? If I move this, this is what it is, what the price is. I want it in terms of what the price should have been. So this 9 by 7 was here. It will flip here to 7 by 9, right? That means what is 2 by 9 less than what should have been. 2 by 9, 1 by 9 is 11.11, so 2 by 9 would be 22.22. So the price, what the price is 22.22% less than what the price should have been, okay? I don't know whether that got covered here. Let me do that again. The price was P. He was supposed to do 9 by 8P, but he ended up doing 7 by 8P. I am already putting it in the numerator by denominator form because this is what I want. What should have been, what is, PP gets cancelled, I get 9 by 7, okay? Another way of doing this would have been to, because I know that we're talking about 9 by 8 and multiplying it by 7 by 8, think of the price as 8 for a minute. The price was 8. It was supposed to be made 9 by 8, so the new price should have been 9, but what he made up doing was 7 by 8 into 8, he ended up getting 7. Now the question is, 7 is what percent less than 9? Your answer obviously would be 2 by 9, which is again 22.22%. So I hope that made sense. Stop. Okay, so more complications here. Since the price of mangoes increased by 6.66%, P dash is 16 by 15 of P, or the new price is 16.66% more than the old price. 1 by 15 is 6.66 increase, so 16 by 15, right? The wholesaler was able to purchase 18 mangoes less, so Q minus 18 is equal to new Q, right? The quantity has reduced by 18. I'm just capturing the information given here so far. And the budget or the expense is 864 rupees, okay? Now, what is the increased price of each mango? So we'll get to that in a bit. So I know that the expense has not changed in the story, right? It has remained 864 only. I know expense is proportional to price and quantity, and quantity is inversely proportional to price. We all know that if the price of something goes up, we are likely to buy less of that particular item, okay? So in this case, for quantity, the multiplying factor for expense is 1, so it will be for quantity also 1. The multiplying factor for price is 16 by 15, but price and quantity are inversely proportional to each other. So the 16 by 15 will become 15 by 16, which will give me the new quantity. So I can see two relationship between quantities. Quantity is reduced by 18 and quantity is multiplied by 15 by 16, and you get to the new quantity, Now I can equate it. I can move this part here, remove this, and this becomes 15 by 16 of Q. Solve this and I'll get the value of Q, right? Is that okay? Sorry. Yeah, right. Okay. Or what I can do is, I can look at, okay, what is happening here is it's getting reduced by 18, right? And here it is getting reduced by 1 by 16, yes? Otherwise it would have been 16 by 16. So there is a reduction of 1 by 16 in this equation, and there is a reduction of 18 in this equation. So I can equate those two. So 1 by 16 of Q is equal to 18. So Q is equal to 18 into 16. Remember, this is your old quantity. Okay, this is what you were buying before the prices went up. Okay, so what would be the price? You got these many mangoes and you spent these many rupees. Now think, for example, you spent 10 rupees and you got 5 mangoes. What would be the price of mangoes? How would you calculate it? You divide your expense by the number of mangoes and you will get your price per mangoes. Essentially it is the same equation, expenses price into quantity, right? So you have rupees per kg into the number of kgs, this gets cancelled, you get rupees. So by the same equation, when you want to find price, it is going to be expenditure upon quantity. This is what you're doing here. So now to find the price would be expenditure upon quantity, or 864 divided by 18 into 16. Remember? Or notice that I have left the number like that only. So this was your old price, right? Okay, but the question is not that. The question is what is the increased price of each mango? So we have got P right there, 864 by 18 into 16, but we are supposed to find P dash. Can I just put it here? So instead of P, I'll put, remember, 864 by 18 into 16. Now the 16 gets cancelled. My final answer is 864 divided by 15 into 18, and that is one of the reasons I kept it in that form, because we're going to still work with the number. Keeping it in the factorized form is always more useful if you've learned the same idea from number system. So I hope the idea was clear. Here we are talking about percentages, but we're also talking a lot about relationship building, translating the information, connecting pieces, etc. The percentage is very little part of it. After that, it's variation and connecting a lot of different ideas, that thinking of price as expenditure upon quantity, etc., etc. So not just percentages, but a lot of other general relationship. Okay, stop. Okay, I hope you spend some time doing this one, because you will see a very elegant solution if you, one, use multiplying factors and percentages, and secondly, understand the basic logic involved in this question. So a large watermelon weighs 20 kg with 96% of its weight being water. So we're talking about 20 kg watermelon and 96% of it is water. So what is the rest of it? The rest of it would be, of course, 4%, because there would be 100% of it, and 4% of pulp, right? That gooey matter inside the watermelon. So there is 96% water and 4% pulp. Okay. Now what happens in the story is that the watermelon is kept in the sun and the water evaporates. Obviously the pulp is not evaporating. So one idea would be to focus on something that is not changing, because focusing on that would be easier, calculations would be easier. So pulp is not changing. What was the pulp earlier? Earlier the pulp was 4% of 20 kg. Okay. Now water we'll work this out later. Now what happens is some of the water evaporates, so that now only 95% of it is water. Now where some people go wrong is that they might take 95% and apply it on this 20 kg. What you have to understand is that when some water went away, the weight also reduced. Okay. Now of this new weight, okay, for example, X water went away, so my new weight will be 20 kg minus X. Now of this 95% is water, that is what is given to me. So once again, I am not interested in what is water. I know my pulp would not change, right? My pulp would remain the same. Now he's saying in the new situation, in the post sun situation, there is 95% water. That means there is 5% pulp. Okay. I do not know what the, let's call it Y, I do not know what the new quantity is, right? That is not mentioned in the story, right? But we're not worried about that. I know the pulp has not changed. The pulp was this much in the story. Now pulp is 5% of Y. Is that okay? So 4% becomes 1 by 25 into 20, or you could have this work this out as 4% of 20 is 0.8 kgs, because you already know this. And 5% is 1 by 20 into Y. So I get the value of Y straight away. It becomes 16 kgs. Is that okay? Yeah. So the equation was very easy. Just equate the pulp part. Pulp was 4% of 20 and it is 5% of something. I do not know what that something is. I mean, I did not know it earlier. Now of course I know. Okay. So equate this two and your work gets done very easily. So what you have to notice is that 16 kg, right? That means 4 kg water went away. So water earlier, if you look at it, earlier pulp was 0.8 kg. So water earlier would have been 20 minus 0.8, which is 19.2, right? Now 4 kg went away. That means 15.2 is left. If I look at this equation, yeah, so if you match that data, you will get that also, right? Though we haven't got that information here. Anyway, so you get so the question was, its reduced weight will be 16 kg. We've already worked that out. Okay, I hope that made sense. Stop.